Okay, now this is the 5D on the 2017. We want to find where is the particle going to be the first time it turns around. Okay, so we have to figure that out, and then we want to, of course, work that out. So when will the object turn around? When the velocity is 0. So I factor this. So positive, negative, positive, 3, 5. So the first time it's going to turn around is in 3 seconds. So what's going to happen is for the first 3 seconds it goes this way, and then at 3 seconds it turns around, 4 seconds, 5 seconds, and then it turns around again and goes this way. So now, so that means we want the first time it turned around, so that means I want P of 3. So now, what you want to recognize is this is a fundamental theorem calculus question. The antiderivative of little f is b minus a. This is the idea that they're testing me on here. They're using physics here, position and velocity, but they should get the same thing. So the integral of velocity from 0 to 3 is going to be p of 3 minus p of 0. Now this is going to take a little bit of work because we don't have the calculator. Would be nice if this was in the first section, but it's not. So I'm going to have to actually grind out this antiderivative. Now p of 3 is what I'm looking for, and p of 0 is 5. So this is called the displacement. So I know when I started I was at 5, and then I'm going to have to adjust by what we call the displacement, how far I move. So 1/3 t to the third minus 4t squared plus 15 from 0 to 3. If I put 3 in, so now I have to do the antiderivative at 3 minus the antiderivative at 0 of this thing. I put the 3 and I get 27. 27 divided by 3 is 9. 3 squared is 9 minus 36. 3 times 15 is 45. So I get 18 if I add that up. So notice that means the displacement is 18. What that means, just to be clear, is that when I started at 0 and I went 1, 2, 3, at 3 seconds I moved 18. But remember, I started at 5. So if I started at 5 and I moved 18, then where did I actually end up at? I ended up at 23. Hopefully that answers your question.